Hello everyone, welcome to this video. In this video, we'll be solving another question which states that if A be a group element having order n, so we are given the order of A as equal to n. So you can write it like this: A raised to power n is equal to e, where n is the smallest positive integer of such kind. And moreover, we are also given that d is a positive divisor of n, right? So we have to prove that the order of A raised to power d is exactly equal to n divided by d. Correct? So in order to prove this, we know that the order of A is n. So you can write A raised to power n as equal to e. Now you can write n as equal to n into d divided by d. Correct? So this is what we have done here. And because A raised to power n was e, so this whole thing is also equal to e. So from here, you see A raised to power d whole raised to power something is e. So that means the order could be, could at least be this number, correct? At most be. Here it should not be at least, here it should be at most, because it is either equal to n by d or it is smaller than n by d. That is by the definition of order, that it is the smallest positive integer of such kind, such that when you raise it to the power of the element, it gives you identity, correct? So we assume that, what is this order? We assume that the order, we are not sure this is the order or not. We have to prove that this is the order. So we assume that the order of this is t, correct? So we wanted to prove this t is nothing but n divided by d. So we are going to prove it by the method of contradiction. So we first of all assume that t is not equal to n by d. If it is not equal to n by d and the order can at most be n by d, hence t has to be less than n by d, correct? So because t, we have assumed this to be the order of A raised to power d from here, so therefore when you take it to the power, when you take A raised to power d raised to power t as equal to e, right? So you have A raised to power dt is equal to e, right? However, because we are given that, we by our assumption we know that t is less than n by d, from here you can clearly see td is less than n, so or dt is less than n. So you also have this expression that A raised to power dt is equal to e. So therefore we found an integer td which is smaller than n, such that A raised to power td is e. So that means this td becomes the order, right? Order of A. However, we are given that the order of A is n, so no number smaller than n could be the order. So this statement is not correct. So this statement is not correct. So whatever we have done previously is not correct. So whatever we have supposed was incorrect. We suppose that t is not equal to n by d. This is not possible. If this is not possible, hence t must be equal to n by d, and this is what we wanted to prove. We wanted to prove that the order of A raised to power d is equal to n divided by d, correct? So I hope you understood this question well. Well, that is it for this video. Thank you for watching.